introduction again. Okay, so I'm like 2 seconds into class, but I'm not recording. 7.3 yesterday, we learned about the inverse method, doing that by hand, and then I also showed you how to do that on the calculator, so you can do it both ways. That was how we solve for x and y. We're learning two new things today that are also solving for x and y and z and w and a and b, whatever variables that we have. So the inverse method was one way. The next way is something called Cramer's rule, and then this is also by hand. Cramer's rule is using determinants in order to find x and y. So again, you're not done until you find x and y. Again, I'll write over here, find variables. That's how you know that you're done. Cramer's rule is using three different determinants. We call them different things. We call it d, we have dx, and then we have dy. Before we do that, so if I'm doing three different determinants, I'm essentially doing three different matrices. Hey, Iz, you guys can help yourself. I'm in the middle of a lesson though, and it's being recorded, so don't say anything too crazy. Thank you for saving me this one. I did not purposely save it, but you're so welcome. You get one first. There are going to be three different matrices. So D, without any subscript, is if I take just the normal coefficient matrices. I'm going to call them A. The coefficients in front of X are A. And then the coefficients in front of Y are B. So my D is finding the determinant of matrix with A as my first column and then B as my second column. Hi, guys. Thank you. You're welcome. I'm giving them away at the end of the day, so if anyone else wants one, tell them to come get it. Dx is if we are not including my X column. So I'm not including A, I'm including B, and then I'm including the last one, which is C. Now, it does not go in ABC order like I want it to. If I'm not including A, then I'm replacing A with C, the answers. So I'm going to put C first and then B. Instead of having A in the first spot, I'm replacing A with C. That is not what I think it should be, so I'm trying to make a big point that it's not in the order that you want it to be. You want it to go B and then C, but it matters that we have C as the first column and then B as the second column. dy is the last one, and that's the determinant of columns not B this time. This time we're just not including Y. So I'm going to do A and C. This time it goes in the order of AC because I replaced B with C. So C has to go in the B spot. So C is the one that switches places. A always is first, B always is second. If you're not using one or the other, then you have to put C in that empty spot. Okay? So let's practice this. So we have to find all three of these determinants. Remember, I thought I went crazy there for a second. Like, what do I hear? Remember that the determinant is the same thing as like A times D minus B times C. So if you forgot what the determinant was, it's like the first and the last number multiplied together minus the two middles multiplied together. So I'm going to do D first. So my matrix for D is columns A and B. So it's going to be, my first column is 3, 2, and my second column is negative 7, 1. There's my B, and then here's my A. Determinant, I'm going to do 3 times 1, and then 2 times negative 7, minus 2 times negative 7. Everybody remember that skill? We learned that a couple days ago. Determinant, that's not new or crazy. 3 minus negative 14, and so that becomes 17. So D equals 17. All right, now I'm going to do dx. That now is my column C and then b. So it goes 9, -6, and then b, which is -7, 1. Again, c goes first, b goes second. If this highlighting is hurtful, let me know. I'm trying to be helpful, but if you hate it, just tell me, I'll erase it. Got to do my determinant. So 9 times 1, and then minus -6 times -7. So 9 minus 42, and that's -33. Yeah. I'm going to tell you in a second. We have to find all 3 of these, and then we'll use them to find y. Why are we doing this? Why are we doing anything? All right, determinant of dy is a and then c. So I'm going to do my a column, which is 3, 2, and then my c, which is 9, -6. Again, there's my a. Here's my c. Determinant is 3 times -6 minus 2 times 9. Perfect. Okay. 3 times -6 is -18, minus 2 times 9 is 18. -18 minus 18 is -36. Okay, we needed these 3 numbers, and I've seen this taught different ways, but I thought it was really simple to find the numbers and then later use them. I told you the whole point was to find x and y, right? The whole point is to solve for my variables. Using Kramer's rule, x is equal to dx divided by d. I just found dx, right? Dx was -33, d was 17, so x equals -33 over 17. I had to find all 3 of those things, so I could find x is -33 over 17. Y is dy over d, so that's -36 over 17. So the reason we did all of those determinants is so that I could set up these 2 fractions. I cannot simplify. 33 and 17 have nothing in common. 36 and 17 have nothing in common, so this is as good as it gets. Those are my answers. Can I prove it to you? Can I prove that this works? Yesterday we did inverse method, right? Inverse method is where I took my original equation and I told you that it was a times x equals b, right? A was my matrix of my coefficients, 3, 2, -7, 1. X was my variables, x, y, and then b was my answers, 9, -6. You guys remember that? And then we plugged in the calculator, or we did this one by hand, but you could plug in the calculator, a to the -1st b. Well, let's put these in. Let's put in 3, -7, 2, 1 for A, and let's put 9, -6 in for B and see if that answer gives me the same thing. These are all very similar. It's the same concept, it's different methods to get to my answer. So let me get my calculator up. Let me put these in. So I'm going to go change my matrix A. I need it to be a 2 by 2, 3 by 2. 3, -7, 2, 1. It can be really annoying to make new matrices, but it shouldn't be something that's hard for us. If you're having a hard time doing matrices and typing them in, please let me know. If you need me to come look at your screen, I'd be happy to. I'm going to edit B now to make it a 2 by 1, and I'm going to make that 9, -6. Make sure it's -6, or else you're going to get the wrong answer. Okay. And then like I taught you yesterday, we can type in A to the -1st and then B. And that should solve, that should find my X and Y for me. When I press enter, it gives me these ugly decimals. Do you guys remember how to make that a fraction? Math. And then the first one says fraction. I'm going to say it 3 more times because I had 7 kids ask me 7 different times during F period out of 5 minutes. Press math, the button that literally says math, and then the very first one says arrow fraction. Press that. It says answer arrow fraction. It means we're taking our answer and making a fraction. Press enter again. Not a fraction. Ooh, do you guys see how we got the same answers we got when we did this by hand? How cool. Go team. So that's why we're doing this. That's why we're finding capital D, dx, and dy. So let's do that for the next example, okay? We're gonna find d, dx, and dy. I'm not writing this cute first part. That's like in the little bit of notes part. Feel free to do that on your own if you want. But I already set it up, so now let's do another example. So I've got x, my y's, my constants. A, B, C. Remember, we have to do d, and then dx, and then dy. D is my AB, so to find D, I have to do 5, 3 is my first column, 2, 1 is my second column. That's 5 times 1 minus 2 times 3. Is 5 minus 6 is negative 1. So D equals negative 1. We're going to do dx next. Remember, dx is not what you think it is. It goes C and then B. We want it to go alphabetically, but it doesn't. It goes C and then B. So if you're C column first, negative 7, 1, and then B, which is 2, 1. Negative 7 times 1 minus 2 times 1. So negative 7 minus 2 is negative 9. So d of x equals negative 9. Anybody questions yet? Okay, and then dy is AC, so it's just not the B column. So I have to do 5, 3 as my first column and negative 7, 1 as my second column. 5 times 1 minus 3 times negative 7. Five times 1 is 5 minus plus 21, which gives me 26. So dy is 26. Now I gotta do x and y. So x is dx divided by d, and then y is dy divided by d. Negative 9 divided by negative 1 is positive 9. (26) divided by negative 1 is negative 26. So pretty nice answers. I'm going to confirm that that's also true. You don't have to. You don't ever have to confirm, but I'm going to prove to you that this is right. And I'm also going to prove to you that we're doing a lot with the calculator and without the calculator. So if you get the calculator, check your work. I will need to see these steps to show, give you full credit, but you can get partial points or at least know if you're going in the right direction by checking your work. So I'm going to again change matrix A to be 5, 3, 5, 2. 3, 1. And I'm going to change B to be negative 7, 1. And I'm going to do A to negative first times B. Oh, perfect. Gave me my answers. Minus x since it's on top, y is negative 26. Okay, any questions? You doing okay with Kramer's rule? All right. Next, we're going to do calculator steps. So we need to get our calculators out. Well, let's kind of talk through with you on this one. We're doing something called the Gauss-Jordan reduction. We also call it row echelon form. And then there's another button called reduced row echelon form. So there's a lot of names for this. Gauss, Jordan are two mathematicians that came up with this stuff. So that's really kind of thing. What I need to teach you first is something called an augmented matrix. So augmented matrix. We get an augmented matrix by taking a normal square matrix. So in this case, we're going to take a normal 3x3 matrix and attach a 3x1 matrix to the end of it. If we were doing more of this by hand, we would have a line that went down that separated my 3x3 matrix with my 3x1 matrix. This is a pretend line that's not in your calculator, but I like to write it. Then again, I did way more matrices by hand than probably you guys will ever do, and that's okay. But I think it's nice to organize it this way. It keeps my thoughts straight. Now, instead of it being a 3x3 and a 3x1 matrix together, it is a 3x4 matrix. 3 rows, 4 columns. So when I enter this in the calculator, I need to make sure my matrix shape is a 3x4, so I have room for all my boxes. Now, this augmented matrix comes from the equations next to us. We've done this before. We've taken these kind of equations and we put them into a matrix, correct? The first column is going to be all of my coefficients for my x. So 1, 2, 3 is my first column. My second column is all my y's. 1, -1, 1, all my coefficients for y's. And then my third column is my coefficient for my z's. -1, 3, 1. If I have a number in the first column, you can think of it as being multiplied by x. If you have a number in the second, think of it as being multiplied by y. If you have one in the third, think of it as being multiplied by z. In a minute, we took an equation, we put it in the matrix to help us solve it. In a minute, we're going to take it out of the matrix, and I had a lot of kids last class confused on how we did that. If you kind of keep in mind that the first column is all x's, the second column is all y's, and the third column is all z's, that kind of helps us keep everything straight. Now, the last column that I haven't written anything in yet, this is your answers. These are your solutions. This is what's by itself on the right hand of the equation. So that's my 2, 14, 14. Okay, there are 2 buttons I'm about to teach you. Let's start by putting this into the calculator though. Enter into your calculator. I'm just going to change matrix A to be a 3x4 with these numbers in it. So I'm going to edit it to be not a 2x2, but a 3x4, and put all of these numbers in. Oops, come back. 1, 1, -1, 2, 2, -1, 3, 14, 3, 1, 1, 14. All right, everyone in the calculator with us? Perfect. I want you to close out of that, so now we're on our main blank screen. Because next I want to press second our matrix menu, and I want you to go over to the second column in your matrix menu labeled math. Don't press the actual math button, just go to the math in your matrix box. I already showed you how to use DET, right? We did that with 3 by. Yeah, stop talking about this. Yeah, that happens in like 30 minutes. It just makes me feel crazy. Okay, so we've already talked about DET, especially with the 3x3 matrix. I want you to scroll down. It goes 1, 2, 3, 4, 5, 6, 7, 8, 0, and then it goes to A, B. I don't have an A, but your guys' A just says REF, right? Yes. REF, and I'm going to write this on my notes. REF, that means row echelon form. I did not think to look up what echelon means. I know that I've used it many times in matrices before, so that was not a new word to me, but then saying it last period, I realized I probably should look up to see if it was a name of somebody or what. But row echelon form is what REF stands for. What that does is it's going to get my augmented matrix down to a 1 along the diagonal and a 0 below the diagonal. So when you press that button in the calculator, what you should get out, I should use a different color. The diagonals will all be 1s, and then all of the numbers underneath the diagonal will be 0s. And so we're going to press that momentarily, but it should go 1. The first column will go 1, 0, 0. The next one will have a number and then 1, 0. And then the last column will be just 2 random numbers and then a 0. The solution column will also just be random numbers. I don't know what those are going to be yet. In a second, we're going to press REF for this and find out what those numbers are. Actually, let's do that right now. I just can't show you it because I don't have it on my calculator for whatever reason. So go ahead. You're already in the math menu. Press A, the REF button. I'm pressing the wrong one just so you can see in my calculator. I'm pressing REF, but we'll look at that in a second. And then you're going to go back into your matrix and you're going to press A. So you're doing REF of A. I know mine doesn't say that, but you're doing REF of A. You get a bunch of crazy decimals. Go ahead and press arrow fraction, so put it in fraction form. And then I'm going to want to know what those are. You might not have liked that. All right, so the numbers are 1/3, 1/3, -7/5 is underneath that 1/3. And then it's 14/3 and -14/5 and 2. Okay, so this is what we get in row echelon form. What this means is now I can take this that's in a matrix and put it into an equation. So we remember that the columns went X, Y, Z, and then my answer. So I'm going to start at the bottom. I'm going to start with my last equation. My last one, I've got no X's, I've got no Y's, but I do have a Z. So I'm going to say Z equals, and the answer is 2. That's cool. All right, the one above that, there are no X's, but there is one Y. And then it goes -7/5 times Z equals -14/5. Everyone okay with that? So again, I'm starting at the bottom. So all I'm doing is I'm taking the numbers in my matrix and making them coefficients for my variables. So anything in the last column is a Z. Anything in the middle column is a Y, and anything in the first is an X. So like the very first equation I wrote was 1Z equals 2. The next one, I've got a number in my Y column. So I have 1Y. I have -7/5 Z, and that equals -14/5. Okay. The last one is going to be, I have 1 in my X column, I have a 1/3 in my Y column, a 1/3 in my Z, and that equals 14/3. So I'm going to write X plus 1/3 Y plus 1/3 Z equals 14/3. All I did was take all the numbers out of my matrix and put X, Y, and Z, and plus signs and equal signs with them. Okay? Now this looks like algebra. I have Z equals 2. I told you you're not done until we have all the variables. So I already have one variable. Now I'm going to go to the equation above it and replace z with 2 so I can find y. You guys can substitute, right? Yes, you can. So it says y plus negative 7 over 5 z equals 14 over 5, negative 14 over 5. We took this equation and rewrote it. But instead of z, I'm writing 2. Substitute in 2 for z. And now I just have one variable, so I can solve for y. Y plus, this will be negative 14 over 5 equals negative 14 over 5. If you hate this plus negative 14, you can just make it a minus. Plus and negative is the same thing as a minus. Now I'm going to add 14 over 5 to both sides. Oh, nice. They're both negative, so they both cancel. So I get y equals 0. Okay, so I've solved for y, I've solved for z. Now I need to use both y and z in order to plug into the first equation to find my last variable, which is x. And you can even write y equals 0 over here to keep everything straight. I'm going to take this equation now over and rewrite it so I've got room to solve it out. Plug 0 in for y, plug 2 in for z. Anybody have a problem with that? Okay, all we're doing is substitution. So this one says x plus 1/3 y plus 1/3 z equals 14 over 3. Y is 0, z is 2. Now we just do some algebra. 0 times anything is 0. 1/3 times 2 is 2/3 equals 14 over 3. Minus 2/3 from both sides. Oh, nice. I don't even have to worry about getting like denominators because they already have it. X equals 12 over 3. Oh, and what's 12 over 3 the same thing as? 4. X equals 4. So x equals 4, y equals 0, z equals 2. I don't know if you solved a lot of equation systems back in algebra 2, but like the reason matrices are helpful is it helps us organize it. If I can do this RR or this REF and find out what X, Y, and Z are pretty easily, we can deal with more numbers and more lines. Now I'm about to teach you an even shorter shortcut. Are you guys ready for that? Okay, so remember I told you there were 2 buttons, one called REF and then the other one called RREF? The RREF is called reduced row echelon form. So my answer now is not just going to be ones on the diagonals and zeros underneath them. It's going to be ones and zeros in the entire first, like 3x3 shape. This is the identity. And then I'm just going to have numbers over here. When I go from my matrix and press RREF, all of my answers are going to just be in this last column. Okay, so let's do it. I already have RREF of A like ready to go on my calculator. If you don't, go back to your matrix menu, scroll over to the second column which is math, and go down to letter B, which is right below REF. Press RREF and then press A, and then this is the answer again. You see how the first answer is 4? What do we get x to equal? 4. See the middle one is 0? That one's also 0. Patrick, I don't have an excuse from you though. Okay. Hey, good luck. Bye. I don't know what my train of thought was, but 402. Those were the answers we just had before, right? RREF spits you out. The last column is all of the answers. X is 4, Y is 0, Z is 2. Now, when I ask for what we did, I want you to do all the substitution we just did. However, if you're already using your calculator, I would go press RREF and see what are the answers I'm trying to get. Let's set ourselves up and say, oh, am I on the right path this whole time? Find out, and then as you go, be like, oh, yes, this was correct. Oh, yes, this was correct. Or like, oh, I got 16 for X. Something went wrong. Let me try that again. Okay? You guys ready to try another one? Question, Daddy? Yes. So if I want, I'll tell you which one. If I want the REF using Gauss-Jordan, I want this one. If I say find RREF or reduce row echelon form, then I don't want any work. I just want this matrix. Mm-hmm. And I'll try and be obvious. I'll say show work or show your substitution so that you know what I'm talking about and you're not like second guessing. I also like have a fair amount of space right here for you to do the work so you know to show it. If it's like one problem and then another problem right on top of it, you don't have any work to show. There's nothing to do. Mm-hmm. All right, let's do the next one. Let's write my matrix from here. So I've got X's and Y's and Z's and W's this time. I've got a lot of variables. So X's first. Now, if there's no X in that line, we make it a 0. So I've got 1, 0, 1, 1. Next, I do my Y's. I've got 1, 1, negative 1, 0. There's no Y in the last equation. Now, these are kind of all over the place, but I've got a negative 1 in the first one and a positive 1 in the last one. So negative 1, 0, 0, 1. And then last I'm doing W. I only have 1 in the second and the fourth row. So 0, 1, 0, 1. Now it's an augmented matrix, so make sure your answer is the last column. So I've got 4, negative 4, 1, 1. And because we're in the same rule as before, this is REF. This REF. Now, before I do REF, I'm going to go like set myself up for success. I'm going to find out what the RREF is. I'm going to find out what all the answers should be, write them off to the side so then I can justify my work as we go. In order to do that, though, I need to put this big matrix into my calculator. And this is a 1, 2, 3, 4 rows by 1, 2, 3, 4, 5 columns. So I need to make sure I fill in a 4 by 5 matrix. Again, I always just change A. You can always do different matrices until you run out, but I like to exclusively just change A and go from there. So once you put your matrix in, I'm going to go do RREF of it. So second matrix, go over to your math menu, not the real math menu, just in your math matrix, go to math. And I'm going to go press B, which is RREF, and I'm going to do that of matrix A, which I just changed to be my matrix. Okay. As you can see, that gives me my answers are 4.5, 3.5, 4, and then negative 7.5. So that means My x should be 4.5, my y should be 3.5, my z should be 4, and my w should be negative 7.5. Just a reminder in case I didn't explain this, again, this is these like should be our answers. This is us kind of like pre-checking our work. A reminder that I had the whole first column was my x's, so the answer for my first row, that's why like, since on my calculator that 1 was in the first column, that's how I know that 4.5 should be my x. Same thing all the way down. I don't know if I did a good job explaining this, which is why I'm doing it now. The second column is my y's, which is why the second row has a 1 in the second column, which I know that's a y, and then so on and so forth. So z is the third one, because it's the third column, and then w is the fourth one, because it's the fourth column. I hope I'm not being redundant, but I want to make sure that works. So I wrote my augmented matrix, and then I wrote an arrow with REF. I need you guys to see that, because if I ask you to do this, I want you to show me that's what you press in your calculator. Because if you get anything different, I'm going to assume you press something else, and I don't know what that is. So make sure you write REF. So what I get out from that is this. 1, 0, 0, 0, 1, 1, 0, 0, negative 1, negative 1/2, 1, 0, 0, 0, 2 over 3, 1, 4, 3 halves, negative 1, negative 5 over 15 over 2. Okay. Remember I told you a minute ago that REF is where you get 1 as the diagonal, and then everything underneath the diagonal should all be zeros. So I can kind of check myself, okay, that looks like we're supposed to have. Now I want to write my equations from here. Remember that my columns went x, y, z, w, and then it equals my answer. I can start at the top on this one. I just started at the bottom last time because I thought it made more sense. So the first one, I have 1 in the x column, so I've got x, 1x, plus 1y, minus 1z, no w's, equals 4. 1x, 1y, negative z, no w's, equals 4. All right, same thing for the next line. This time I have no x's, so it's going to be y minus 1/2 z, also no w's here, equals 3 halves. Okay. Next one, I have no x's or y's, but I do have a z. Z plus 2 over 3 w equals negative 1. And then last, I have no x, no y, no z, but I do have a w. W equals negative 15 over 2. All right. So we already kind of know what our answer should be because we checked with reduced row echelon form. What I'm going to do now is I got to do all my substitution. Which variable do I already know? W. I already know W. So now I'm going to replace W or with negative 15 over 2 or with negative 7.5. I don't care what you do in all of my equations. Well, right now, only the equation above it with Z in it has W. So let's substitute there and let's see if we can find Z. Then we can keep substituting, okay? Go for it. I've got Z plus 2 over 3W equals 4. No, it equals 1. What did I write 4? Equals negative 1. I'm really quick. So I took the third equation and I am going to substitute in negative 15 over 2 for Z, no, for W. Okay, lots of letters. I know W equals negative 15 over 2. I'm replacing W in this equation with negative 15 over 2. And that just leaves me with one variable of Z to solve for, which I can easily do. 2 over 3 times negative 15 over 2. I've got a 2 I can cancel out. 3 and 15 actually have a common factor of 3, so I have negative 5. So it's essentially Z minus 5 equals negative 1. You're welcome to do those as decimals or whatever the whole way through. It worked out to a whole number, so it's okay. Add 5 to both sides, and I get Z equals 4. Is that what I thought Z should equal? Yeah, nice. That's what was over here. Okay, so 4 looks good. Negative 7.5 is the same thing as negative 15 over 2, so those are good. Now let's find Y. So I have to do my Y equation, which is right here. Now I don't have a W in there, but I do have a Z in there, and I just found Z to equal what? 4. So I'm going to substitute Z and 4. So I've got Y minus 1/2 times Z equals 3/2. We know Z equals 4 because we just found it. Now we're just solving with algebra. Just substitute that in. 1/2 of 4 is 2, so I've got Y minus 2 equals 3/2. And then I add 2 to both sides, which is going to be 3.5. Or if I want to keep it as a fraction, I could add it as 4 over 2, and that's 7/2. Y equals 7/2, or 3.5. Is that what we had Y to be when we did RREF? All right, things are looking good so far. I got one more. The last one is X plus Y minus Z equals 4. So I could put Y as 3.5 or 7 over 2. And Z is going to be 4. And we're going to find X. X plus Y minus Z equals 4. Remember that Y is 3/2. Z is 4. Okay. I'm going to add 3.5 and negative 4 over here. So X minus 0.5 equals 4. Add 0.5 to both sides. X equals 4.5. If you wanted to keep it as decimals, it would have been minus 1/2. And then we could make it 9 over 2. Those are the same thing. Is that what we got last time? Is that what we got that the answer should be? Yeah? Awesome. Okay. We have some time, so I'm going to keep working through C. This is where we stopped with my other class. So at this point, I am assigning 7-3 homework, even though we've got a couple examples because I think I've done enough examples. But I've got 7 more minutes of class, so I'll keep working through C and talk through it if you want me to. We'll look at D later. For your quiz on Tuesday, your little baby quiz, I'd focus on 7-2. I anticipate asking you things that you can't use a calculator for because I want to make sure you can add and multiply matrices by hand. Does that make sense? So nothing calculator wise. We'll do calculators on our normal quiz that's going to be on Friday. So baby quiz, no calculator, 7-2. Okay. I'm going to do letter C. Got to make my augmented matrix. 1, 2, 1, 1, 3, 2, negative 1, 1, 2, 10, 7, negative 3. Again, my x's went first, my y's went second, my z's went third, and then my answers went last. Okay. I have to do REF of this, so I got to enter this in the calculator and see what I get out. I know it's going to be 1, 0, 0, something, 1, 0, and then something, something, 1. And then I'm going to have all 3 just kind of random numbers over here. So I can kind of know this is what it's going to look like. I've not done this one, so I hope it's not a weird one. I'm sure I just got that in pictures. Once I put my matrix in, I'm going to set myself up, see what my answer should be. So again, this is my RREF off to the side. This is my REF right here. Now, the problem is I wanted it to be a really pretty identity matrix, but it's not. I have 0 and 0 here. I've got 3 and negative 13. I've got 7 over 2. I'm talking really weird order, so make sure you look at what I'm doing instead of just listening. Okay. My equations, my bottom is just 0 equals 0. There's no variables. My second one is no x, but there's a y plus 3z equals negative 13. And then the first one is 1 plus 3 over 2y plus 1 over 2z equals 3 over or 7 over 2. That's my answer.
you get a part where you have this 0, 0, we're just going to write infinitely many solutions. What did I just try to spell infinitely? Infinitely. I think I did that right. Like, some of my like worst skill. So that's maybe okay. If you suck at spelling like I do, I am asked for infinitely many. So if your bottom line is all zeros, it's just infinitely many solutions, all it is. Oh, so got a nice little special example in there. And again, we'll look at D and then keep moving from there next week. Anybody have any questions? Now, I will be posting a 7-1 video, especially my last year was having a little trouble substituting. And you guys are very quiet, so you might also need a review on substituting or elimination. So I'm going to make a video for 7-1, and I expect you to watch that and also do that homework as well. I'll post that later, so make sure to keep an eye out for it.
Well, I really had high expectations last week and I didn't do it. I'm gonna stop my share and stop my recording though.